Hello. So this is the last chapter of this semester. So the last chapter is about the linear regression analysis. Maybe you have heard about regression somewhere if you took any statistics course or any applied economics course. I can say that I'm telling you that like more than 90%, at minimum 90% of applied economics research is based on the regression analysis. And so you can think that the reason why economic statistics is required for econ major is because you need to understand the regression to understand like data analysis in any economics, right? So let me start. So basically, simply speaking, the goal of regression analysis is to predict the value of a certain variable of interest on the basis of other variables. So we would like to use some information to predict another variable. This is pretty typical in many economic analysis. And to do that, we are going to apply all the theories we have used so far. So remember, we started from the basic concepts of probability, mean, variance, standard deviation, and then we learned normal distribution, sampling distribution, the central limit theorem, and then we applied those central limit theorem and normal distribution theory to estimation, like point estimation, confidence interval, and then hypothesis testing, calculating the p-value, the t-statistic, the critical values, right? So we are going to use all these tools to predict something. Exactly, that's what you're going to do. So let me start with a pretty simple question. Like, in the introductory course, you must have learned marginal cost and fixed cost, right? I believe you understand what they mean. So assume that when you produce something, like say, like what do I can I say? Say when you make a smartphone, suppose that the fixed cost is 10 and marginal cost is 2, right? So then among these 5 statements, find one that is wrong, or all of the above may be correct. So this is a microeconomics question. So it is totally fine if you choose a wrong answer. Okay. So think about this. The fixed cost is 10. That means you have to pay $10 no matter how much you produce. That's the definition of the fixed cost. And when you produce 1 unit, the cost is $2 per unit. So let's think about this. When you produce 5 units, then the total cost is 10, the fixed cost 10 plus 2 times 5. So this is correct. And when you produce 1 more unit, the total cost increases by 2, which is the definition of the marginal cost. When you produce 10, then the fixed cost 10 plus 2 times 10 is the total cost. The total cost is 30. So 30 divided by your production is 3. That's the average cost, right? So total cost is 30, but you produce 10. So per unit, on average, you got $10. You paid $10, costed $10. So this is the difference between the marginal cost and the average cost, which you must have learned in introductory course. And D, if the budget is $40, you can produce up to 15, right? So fixed cost is 10. So from your budget, you have to pay $10 upfront, and then for the remaining $30, you can produce 15 because the per unit cost is 2, right? So at most you can produce 15 units. So in the end, it's clear that all the 4 statements are correct. So it is a pretty simple question. Right. So then the reason why we are doing this is in microeconomics, introductory micro, intermediate micro, you learned this theory. So given the marginal cost and the fixed costs, you learned how to calculate the total cost, how to calculate the average cost, and how to maximize your production given the budget. However, in practice, think about this. That's the textbook example. But in practice, if you own a factory, and the main problem, you need to analyze your production and your cost. But the first problem you have to handle is estimating the fixed cost and the total, the marginal cost. So it would be nice. It's actually pretty simple when you know this number. If these numbers are given, of course, in reality, the numbers will be a little more complicated, more dirty, but not a big problem. Anyhow, you can calculate the numbers as long as they are given. But bigger problem is you don't know these numbers, those parameters. So first thing you have to answer is to estimate what is the marginal cost, what is the fixed cost. It is not easy, of course, because they are usually unknown, because random errors can happen, and also what you observe is just you paid, say this year the total cost was a certain amount, several like thousand or $1,000,000. But on the other hand, I sold this much. I manufactured like several thousand, millions of units of smartphones, for example. Then, but from the cost, in accounting, there are many different types of costs. Operation cost, whatever, I don't know. But so you have to estimate the relationship between your production and cost. That's a totally different thing from accounting. And also, as I said, random errors can occur. Like accounting error may happen, and errors in production may happen. You may miscount your actual production, or some manufacturer. There may be some manufacturing mistakes, so you may lose some of your productions. They may not be good enough to sell on the market. So in the end, a lot of things happen in reality, and that's the data. That's your data. So the first thing you have to do before applying economic theory is to find the parameters. The parameters you are given in the textbook are actually not given in the reality. In practice, you have to find them first. That's the reason why we require economic statistics for our majors, and that's why you learn the regression method. So I'm going to describe the basic idea how to find them. So then, yeah, exactly. That's what I exactly explained. You'd like to answer those questions, like the statements. These are actually answers to the question you need to calculate, but you don't know the parameters. That is the main problem. So then imagine what in practice, what you observe is not the parameters, but numbers like this. Say from your factory last year, you observe the monthly output and monthly cost. So for example, in January, say you produced, say 2 tons. I don't know, you can think about any units. 2,000 smartphones or 2 tons of whatever, yields, like agricultural yields or whatever. So the unit output is 2 and the cost is 15. You can put $1,000, $1,000,000, whatever. And in February, to produce 3 units, you had to cost $15. I'll just call it $15. And in March, 4 and 19. And in December, you produced only 1 unit, but there were $9 paid. So in this way, you observe the cost and the output, but from here you have to identify how much was the fixed cost and how much was the marginal cost, And also, how much was a possible error? There might be some kind of error in accounting, in production, and in many different steps. Okay, so imagine this data and imagine how you can answer the questions I showed you in the example question. Okay, so first thing what we are going to do, the first thing we are going to do is to make a scatter plot to study the relationship. Basically, estimating the marginal cost and the fixed cost is statistically finding their relationship, correlation, covariance, and trend line that we learned in the previous chapter, right? So, like marginal cost is the increase in cost when you produce more units, more products. That's exactly what we studied in the previous chapter, correlation. And fixed cost is also related, so I'll show you that. So this is the scatter plot. There are 12 months on this scatter plot. So there are 12 dots. Each dot is 1 month observation. And you see, like when you produce less, then of course the cost, total cost, it must be total cost, monthly cost was lower. So there is a clear tendency, increasing slope, the positive direction of the relationship is clear between the output and the cost. Yeah, of course, definitely the marginal cost must be positive. So as you produce more, you have to spend more cost. That's obvious. But also, what you can see here is the trend is clear, pattern is clear, but it's not perfectly linear. There, for example, there are 2 months where when you produce exactly 4 units, but their total costs are different. Maybe it's because of some kind of errors. Some error happened. And also there are 2 other months producing 5 units. Their cost is closer but different. So even if you produce the same amount, still the observed total costs are different for some reason. That happens. So I don't know why, but this happens in data. So you have to acknowledge that, admit that. So then find a way to understand and handle those errors, right? Okay, this is a scatter plot. Then our goal is to make a trend line that fits those dots, right? So to do that, we are going to set up an equation. This is the linear regression model. We are going to, as before, we will consider only the linear relationship. Like later, like if you study statistics more, then you can extend this model to nonlinear case, like quadratic, cubic, or like taking log, exponential. Different types of functional form is possible, but we will restrict our attention to the linear relationship because that's simple enough. So in most cases, that's general enough. Linear relationship is usually what we are interested in. Okay. So here I will put those notation for each term. Like the total cost we observe will be denoted by y. That's what we would like to explain. It's on the left hand side. So y is the output. Total cost. That means what we are going to predict later. And x is the output, how much we produce. So it's here. Then this equation means when you decide to produce this much, we would like to predict how much it would cost, right? When you decide to produce 10 units, we would like to estimate what would be the total cost. And the parameters are beta 0 and beta 1. Beta 0 is the fixed cost because even if you do not produce at all, no matter how much you produce, no matter how much your output is, beta 0 is included in the cost. So you have to pay beta 0 upfront and then start production. So that's the fixed cost. And beta 1 is the slope, is the coefficient of your production. That is, when you produce one more unit, if x increases by 1, then y increases by beta 1, right? This is marginal cost. And finally, we allow an error term. It's an error, epsilon. So we call it like the Greek letter, epsilon, captures possible errors that happen somewhere in this data. So this makes a linear regression model. This is what we are going to estimate. So then, like, there are 5 components in this simple equation, and so let me classify what those variables. First, you should be able to tell what's observed and what's not. So y and x, the total cost and the total output, are what you observe. So that's exactly the data. So your data only gives you y and x. And beta 0 and beta 1, the fixed cost and the marginal cost, are the unknown parameters. You would like to understand, or you'd like to estimate beta 0 and beta 1. That means, obviously, they are unknown. They are not observed. And also, error term is also unobserved. That's the definition of error. You don't know how much is the error. If you knew the error, then you know the exact amount. So that's not realistic. So error happens, but you don't know how much was a random error. So it is also unobserved. And in another dimension, you should be able to tell what is random and what's constant. In here, so remember, random, when you say random, that means like, so we say something is random when that object can change in another experiment. If you repeat an experiment, if something can take different value, then that's random. In here, one experiment is 1 month. 1 month of production is an experiment, right? So in that sense, you have 12 observations or 12 experiments from the data. So the cost and the output can change from month to month. So they are random. And also, the error term is also random by definition. So error can change each time, every time, so it is random. However, the fixed cost and the marginal cost must be constant. If the fixed cost changes every month, then there is no point of estimating the fixed cost from the past, because next year the fixed cost will be different. So there is no point of analysis. So when we do this analysis, of course, we assume that the fixed cost last year would be the same in the next year, or the marginal cost must be the same in the next year. Otherwise, we don't need to estimate that. So implicitly, we assume that the fixed cost and the marginal cost do not change. If you think they change, then you need a more complicated statistical methods to handle the evolution of the costs. But for now, I'm going to assume that the fixed cost and the marginal costs are constant, do not change over time, so that we can estimate that, and so that those can play the role of parameter in our estimation. Okay, so simply speaking, in the end, we would like to estimate beta 0 and beta 1. Those are parameters, and using the data on observations on the cost, the output and the cost. So these are the elements of the linear regression model. Okay, so in the next video, I'm going to generalize. So also, actually, it's general enough, clear enough, but we will generalize this idea and what we are going to do in the next video. I'll explain that in the next video. Thank you. Bye.